Welcome to this puzzle session. Here is the problem. We have 2n-1 rooks placed on a 2n-1 cross 2n-1 chessboard. Assume that no rook threatens the other. So one needs to know how rooks behave on a chessboard. This is what they look like, and if you just do a quick Google, you can figure out how rooks are supposed to move on a chessboard and what do they threaten. So I'm assuming you're familiar with that much about chess. We want to show that any n cross n square contains at least one rook. So under this constraint, it must happen that any n cross n square in the big 2n-1 cross 2n-1 chessboard must contain at least one rook. So that's very interesting. And as usual, you're encouraged to pause the video before we look at what I'm going to discuss. And now let us continue. So let's make some very simple observations. So since no rook threatens any other rook, it must happen that each column has at most one rook. Because if there is a column with at least two rooks, those two rooks will threaten each other. Okay, but since the number of rooks is 2n-1 and the number of columns is also 2n-1, it follows, using the above, that actually each column has exactly one rook. Right? So this implies that because the number of columns is same as the number of rooks. And by the same reasoning, each row has exactly one rook. So we have these observations. And now let us get to the solution. So I will illustrate the solution only for n equals 5. So that 2n-1 is 9, and I have drawn a 9 cross 9 chessboard. And I have isolated a 5 cross 5 square. This is just convenient for illustration. You can choose any 5 cross 5 square. It doesn't even have to be contiguous. I have chosen these 5 things as contiguous. It doesn't have to be. The argument is not sensitive to this. But it's just easy to illustrate the proof with this simplification or apparent simplification. Okay, so let's assume that there is some 5 cross 5 square or other. Okay, so I want to show that this 5 cross 5 square has at least one rook. And by way of contradiction, we will assume that there is no rook here and somehow produce a contradiction. So we are assuming there is no rook here. Now just focus on this part of the board. This column has exactly one rook and there is no rook here, so there is at least one rook here. By the same reasoning, there is at least one rook here. Again, because there is no rook here and each column has exactly one rook, so there is exactly one rook here. Similarly, there is one rook here, there is one rook here, and there is one rook here. Now these are 5 columns. And within this region, this has one rook, this has one rook, this has one rook, this has one rook, and this has one rook. Therefore, there are 5 rooks within this region. Okay. But if there are 5 rooks within this region and there are only 4 rows, some row must have at least 2 rooks. Right? This is common sense or the pigeonhole principle, if you like. The 4 rows accommodating 5 rooks means there is at least one row which has at least 2 rooks, and that is a contradiction to the observation that we have already made, that every row has exactly one rook. Okay, so that's the proof. This argues that if we assume this region does not have any rooks, we will reach to a contradiction, and hence this region must have at least one rook. And you can generalize for any n, the same reasoning goes through. So with that, I want to end this. As usual, like, comment, share, subscribe, and I will see you next time. All right.